Hello everyone. This video is on the Knewton Alta assignment for section 12.2, part 1, called Hyperbolas centered at the origin. So in this video, I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same and the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you're working on the assignment on your own. Alright, so on your assignment page you should be seeing the title, the mastery bar, right, that tells you how far along you've gotten, the objectives. It looks like there are 4 objectives for this particular assignment. Under the current objective, you should be seeing a question related to that objective. And at the bottom of every question, there should be a feedback button, right, where you can send feedback to Knewton if you wish. You will not have the instructor cheat button, right, that's for instructors only. But you will have a more instruction button. If you're ever struggling with a topic or a question, try clicking on this and it'll take you to a page with some further reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so before I get into the actual questions here, I want to talk about these things called hyperbolas. Right, the first objective I'm looking at here is graph a hyperbola centered at the origin, from an equation in standard form. So let me get into those first before we get into this question. So hyperbolas, centered at the origin in standard form. Alright, so there can be 2 different versions of the standard form equation. The first of these is going to be starting with an x squared term. What you'll notice is that the equation for a hyperbola in standard form is very similar to the equations for an ellipse. Remember from section 12.1, an ellipse in standard form. The only difference is with an ellipse you have a sum of squares equal to 1. With a hyperbola we have a difference of squares equal to 1. Right? So the first version I'll show you is this: x squared divided by a squared minus, alright, then y squared divided by b squared equals 1. Right. Now, what does all this stuff mean? Right. So I'll put up the xy plane here. So again, if it's just x squared and just y squared, the center's the origin. Right, the center of the ellipse is 0, 0. And I'll mark that down. Here is the center. Now, we're going to be seeing, like I said, 2 different versions of this. One where x squared is the first positive term and then y squared has the negative coefficient, and then the other way around where y squared is the positive and then x squared has the negative coefficient. If the x squared term is the positive term, the leading term on this side, then the x-axis is going to be what's called the transverse axis of the hyperbola. The transverse axis. All right, and again, that's if x is the positive term and y is the negative term. So I'll indicate that here with like a dotted line. All right, again, this is not actually on the graph, right? A dotted line. All right, this is the, again, what's going to be called the transverse axis. Right. And then perpendicular to that, going through the center, is called the conjugate axis, right? So if the x-axis in this case is the called the transverse axis, then the y-axis in this case is what's called the conjugate axis. Again, I'll do make a dotted line on the y-axis here. Again, this is not actually part of the graph of the hyperbola. You know, these are not solutions of the equation. And this is again the conjugate axis. Okay. All right. Now, these letters, the lowercase a and the lowercase b, just like with an ellipse, you know, they mean something. They help us find certain points on the graph, right? Certain solutions of the equation. Okay, so the value of a, this will be the distance from the center to one of the points called the vertices of the hyperbola, right? And ellipses had vertices as well. So do hyperbolas. So the distance from the center to a vertex. Right? So from the center, and vertices, by the way, these vertices will always be on the transverse axis. So from the center, I go to the right, you know, A units, and then the left A units. So I'm at A and the opposite of A on the x-axis here. These are actually going to be points on what's called a hyperbola. So there's a vertex, there's another vertex, and I'll label them. Vertex at a comma 0, and here's another vertex at negative a comma 0. And these vertices are going to be solutions of the equation. Right, if you plugged in a for x and 0 for y, or negative a for x and 0 for y, you'd have 1 minus 0 equals 1 in both cases, right, which is true. These are actually solutions of the equation. They belong to what's called a hyperbola. All right, now for the value of b, in this case, b will give us the rise of the slopes of things called asymptotes, right? You've heard the word asymptote before: vertical asymptote, horizontal asymptote, slant asymptote. What we're going to see with hyperbolas is that they're going to have two slant asymptotes, or just two asymptotes, that the curve will get closer and closer to touching but not actually touch as we go further away from the center. So in this case, when x squared is first minus the y squared term, the lowercase b will represent the rise of the slopes of the asymptotes. Now here's what I'm going to use B, how I'm going to use B in a graph. So I went right and left A, B is under the Y, I'm going to go up and down B. So say we go up to B on the y-axis from the center, and down B to negative B. And then what you're going to see in the graphs in this assignment especially is a picture like this, where right A, left A, right B, up B, down B from the center. You create this little box, little rectangle. Right. And the width of this rectangle is 2A, the height of it is 2B, right? And these asymptotes that are being mentioned, right, the slant asymptotes, these run through the corners of the boxes and through the center. So here's an asymptote. Right, there's one of the slant asymptotes for this hyperbola. And again, I'm making all these dotted because they're technically not solutions. They're not on the hyperbola. The only points that are on the hyperbola so far are the vertices. And then through the other corners in the center, right, there's the other asymptote, the other slant asymptote for the hyperbola. Right, so another asymptote. And then once you have the center and the asymptotes and the vertices in, you should be able to make a rough sketch of the hyperbola. A hyperbola is just two almost parabola-looking shapes that oppose each other. So here, again, they kind of follow along this box and toward the asymptotes. So something like that. As you go further away from center, the curve gets closer and closer to the asymptote without actually touching it. And then the same thing down here. Right, and this is called one branch of the hyperbola. So all these green points I just drew are solutions of the equation, supposedly. Right? And then the other branch of the hyperbola runs through the other vertex and approaches the asymptotes, again, as you get further away from the center. So something like this. Okay. And there, these two branches are actually the graph of your hyperbola. Alright, and then we've got one other thing to worry about, and that's the just like ellipses had two foci, right, two focuses, so do these hyperbolas. Right, these have two foci, and there's going to be another letter C, just like with an ellipse. Right, there's going to be a letter called C, a number called C, and C is going to be the distance from the center to these focuses, right, to these foci. I know this is a lot here, but hopefully after several examples, you'll get used to this, all these letters and all this stuff. It's the distance from the center to a focus. Right, and one note here, just like how, the vertices are on the transverse axis, right? The foci are also on the transverse axis, right? They're going to be on this same line with the vertices. So foci are also on the transverse axis. All right, so if I go from the center, I go to the right C units and left, to negative C. Here are what are called the foci. Right. So again, this is not a solution. So here's a focus at C0. Here's another focus at negative C0. Right. And another thing too, these foci should always be inside the curves, right? Not between them. They're going to be surrounded by the curves, these foci. And you may recall from an ellipse, right, back in ellipses, c squared was a squared minus b squared. Right, and a had to be bigger than b in an ellipse. Here it won't matter. All right, that's going to be the tricky part. I know they're using the same letters for the same, for two different things, but here, a squared and b squared, it's going to be always a squared under the positive term denominator and b squared under the negative term. It won't matter which one's larger. All right, a can be bigger than b can be bigger than a, and you're going to have to remember this relationship, that c squared for a hyperbola will be equal to a squared plus b squared. All right, not a squared minus b squared. This is a relationship you're going to have to remember to help us find these foci. Right. Now, why are foci so important? Right? Why do we need to find these focuses, these foci? Well, you might recall again from section 12.1, remember for an ellipse, remember in an ellipse, in an oval shape, there were the two foci, and if you took any point on an ellipse and added the distances, if you added the distances to the foci, it was always the same number. It was always twice a. Well, something very similar here. If you take any point, so here's a point x comma y on the hyperbola, right? A point on this branch or a point on this branch. Take the distance to one focus. Well, let me say the distance to the farther focus, the larger distance. I'll call that d1. Sorry about all the clutter here. But if you take any point on the hyperbola, take the distance to one focus and then the distance to the other focus, and then take the difference, d1 minus d2. Oops, sorry. d1 minus d2. This will always be a constant. It'll always be 2 times a. Right, so that's, and I guess you could put absolute value signs if you forgot to do large minus small. But this is saying, for any point on a hyperbola, the difference in the distances to the foci is constant. All right, it's always 2, whatever 2a is. All right, whatever 2 times a is. And yeah, this is a lot. I understand. Right? There's a lot of stuff to think about here, a lot of stuff to remember. But again, I'm hoping after several examples, we'll get the hang of it. All right, and this was the first one. All right, x squared over a squared minus y squared over b squared equals 1. Again, if the x squared term is first, is positive, and y squared is the negative coefficient, your branches of the hyperbola open left and right. They oppose each other this way. The transverse axis is the x-axis. Well, for the second case, all the letters will mean the same stuff. I'm just going to switch the x and y. Just switch x and y, and then the branches will open up and down instead of left and right. And lowercase b will be the run of the slopes instead of the rise. And we'll have to find equations for the asymptotes too, but they're just lines. You should know how to write equations for lines. All right, so yeah, so the second one is very similar. It's going to be y squared divided by a squared, right? It's always a squared under the positive term, right? It doesn't matter which one's bigger this time. Minus, and then x squared over b squared equals 1. And again, the center is the origin. If it's just x squared and just y squared, center is 0, 0. So I'll do the same kind of labeling here. So center at the origin. But this time, if the y squared term is the positive term and x squared is the negative, then the y-axis is going to have the vertices and the foci on it. The y-axis is that transverse axis. Right. So again, I'll dot that in. Here's the y-axis. This is the transverse axis. This is going to be the line with the foci and the vertices on it. And if the y-axis is the transverse axis, right, perpendicular to that going through the center, right, the x-axis must be that conjugate axis. Right. So again, just dotting this in here and label it, right, there's the conjugate axis. And remember, A represents the distance from the center to the vertices, which in this case will be above and below the center. So here's a vertex at 0a and a vertex at 0, negative a. And these are and the vertices are actually solutions of the equation. There's a vertex 0, negative a, there's a vertex at 0a. The only major difference here is that B, A is still the distance from the center to a vertex. B this time, I'm going to be going left and right B because it's under the x. Right? No. It's going to be the run of the slopes of the asymptotes this time instead of the rise. So from the center I go right B, left B. And again, I can create this little box. You're going to see this little rectangle in all the graphs on the in this assignment anyway. Create this little box here with a height of 2a and a width of 2b. And then through the corners in the center go these asymptotes. Right, the graph will approach these asymptotes as you move further away from the center. But this time, again being y squared minus x squared, the branches of the hyperbola will be opening up and down. So you have this one curve like this that's opening up, and the other branch of the hyperbola opening down. And it's all symmetrical, right? If you flipped across the x-axis, you get the same graph. It should be very symmetrical about the center. And then that same relationship where c squared is equal to a squared plus b squared, right? Plus b squared for these hyperbolas. And you can find the foci, right? C it'll be on the transverse axis. So c units above the center, c units below the center, and here are the foci. Right, there's a focus. And down here, here's another focus. Okay. And once again, if you were to take any point on the hyperbola, right, on either of these branches, take any point, take the distance to one focus, call it D1, and then the distance to the other focus, call it D2, the absolute value of their difference, or if you just make sure you do large minus small, will always be 2a, always, right, no matter what point you choose on either of these branches. Okay, so again, I know this is a lot of writing, a lot of letters and whatnot, But let's take a look at some actual examples now. And of course, I'll also go to the desmos.com, free online graphing calculator site. We'll look at some better pictures of stuff like this. All right. So the first example I'm given, the first equation, is actually one like this second version here. We have y squared divided by 16 minus x squared divided by 36, right, equals 1. Right, equals 1. Should always be equal. So here's your y squared over a squared, right, just like this one, the second version I showed you. It's like y squared over a number, that's a squared, minus x squared over a number, that number is b squared, equals 1. Right? So when I go to graph this hyperbola, the solutions of this equation, it's going to be one where the transverse axis is vertical, is the y-axis, and then the branches open up and down. Right? Okay. So once again, the center is at the origin, and that should be the case for all the problems in this particular assignment. And I'm going to make a rough sketch over here, and we'll look at a better picture in Desmos and then actually make it in the assignment as well. But the center's at the origin. If it's just x squared and just y squared, right, the center's at the origin. And I'm not going to draw the transverse axis in, but the y-axis will be the transverse axis. All right. So the vertices, the foci, are going to be on the y-axis, above and below the center. So we see here that a squared, this first denominator under the positive term is 16, meaning that a is 4. All right, so I'm going to go 4 units above the center. There's a vertex, and 4 units below the center, there's another vertex, right? So we can tell you what the vertices are going to be right now. One vertex is going to be at 0, 4. The other vertex will be at 0, -4. Right. So 0 and then plus or minus 4. Right? There's the vertices. And these are actually solutions of the equation. Right? These are actually on these things called a hyperbola. If you were to put in 0 for x and then 4 or -4 for y, you'd end up with 1 minus 0 equals 1, which is true. Right? These are actually solutions. Then the denominator under the negative term in these hyperbole equations, that's the b squared, right? B squared is 36. So b is 6. Right? And this is going to be the run of the slopes of the asymptotes. Now these don't actually give you points on the graph, right? I'm going to go from the center, 6 units to the right. Not going to put a point there. That's not an actual, if you plugged in 6 for x and 0 for y, you'd have 0 minus 1 equals 1, and that's not true. So I'm not plotting a point there. I'm going 6 units to the right of center and 6 units to the left of center, and then forming that little box and the asymptotes. Right, this box where that has the vertices on them. Right, the height of it is 8, which is 2a. The width of it is 12, which is 2b. And then through the corners, you see this point 6, 4, and this point -6, -4. There's an asymptote going through those 2 points, and also through the center. Right? And we have to find the equations of these asymptotes. Right? So once I have this, I can tell you the asymptotes. Oh, I'll write the equations of the asymptotes after I draw them in. So then through the other corners of the box in the center, this point -6, 4 and 6, -4, through those 2 points and through the center there's another asymptote. Right. And the equations of these asymptotes, they pass through the, the y-intercept is 0, 0, and the slope would be, 4 over 6, rise over run. So 2/3 and negative 2/3 as well. Right? So one of them is y equals 2/3 x. Right? Because again, rise 4, run 6. So there's y equals 2/3 x, right? That asymptote. And the other one's just negative 2/3 x. They just have opposite slopes, right? Because I go down 4, right 6. So the slope is negative 4/6, or negative 2/3. And again, the y-intercept is at 0, so y equals mx plus b, y equals 2/3 x plus 0, y equals negative 2/3 x plus 0. So y equals positive or negative 2/3 x. And those are the asymptotes that this graph will follow. And then once you have the vertices and the asymptotes in, you can make a rough sketch of the hyperbola. Should be doing this. All right. Again, as you use the box as a guide and the asymptote as a guide, right? The branches, these curves, should be approaching the asymptote, but not actually touching it as you move away from the center. Same thing down here, and then they should be pretty similar looking, just reflected. All right, something like this. Again, this isn't great; it's a hand drawing, but there's the graph of the hyperbola. All right, all the points on this curve, all the points on this curve. Should be solutions of the equation. They should satisfy it. Alright, and then I know they're not asking for it, but they will be in some of the other problems. So I'm going to find C, and we'll talk about the foci. C squared is a squared plus b squared in these hyperbola. So that's 16 plus 36, which is 52. Right. So C is the square root of 52 units, right? Now the square root of 52, I mean that's 4 times 13, right? So that's 2 times the square root of 13. And the square root of 52 is going to be between 7 and 8 units. So again, and the foci will be on the transverse axis, in this case the y-axis. So 5, 6, 7, 8. So somewhere between 7 and 8, there's one focus. Right, here's 0, comma 2 root 13. Right, there's one focus, and then the other focus, negative 5, negative 6, negative 7, negative 8. Will be between negative 7 and negative 8. Will be the square root of 52 below the center. So here's 0, negative 2 root 13. There's the other focus. Right? So the foci we can find are at 0 and then plus or minus 2 root 13. And again, the whole reason we're finding the foci in a lot of these problems, the whole reason they're important is this. If you were to take any point, right, any point xy, any point on one of these branches, take the distance to one focus, the distance to the other focus, and subtract them. So again, d1, d2, their difference, right, and I'll make it positive by putting absolute values around it, but the difference between those should be 8. This is for any point xy on the hyperbola. It's always going to be whatever 2a is. Now you're not going to have to really say all that, but I just wanted to point that out, right? Why we're finding the foci. All right, let's take a look. All right, let me actually go to that Desmos website now. Desmos.com, right? Free online graphing calculator. And I'll put in the equation we were given as y squared divided by 16 minus x squared divided by 36 equals 1. All right, you see those two branches show up, right? Those two curves, one opening up and one opening down. All right, and then what I'm going to do also, and it definitely center the origin there, and there's 0, 4, right? Bottom of that one curve. 0, negative 4, the top of the other branch, the top of the other curve. There's the vertices. And what I'm going to do also is graph the asymptotes, right? Y equals 2/3 x and y equals negative 2/3 x, right? These are the asymptotes. You see them going through the center there. I'll make them the same color and dash them, make them like dotted lines instead. So both blue dashed lines here. And hopefully you see now, right, the red graph is the graph of the actual points in the hyperbola, the actual solutions. And you see as I move further away from the center, you know, that graph gets closer and closer to these asymptotes, right, but not actually touching them, right? And that's the case for both of these curves, both of these branches. As you move further away, they get closer and closer to becoming those asymptotes without actually, I mean, the further away you do it, it basically looks like they do form those two straight lines. They're not actually, but the further away you zoom out, it'll look like they're basically those two asymptote lines. Okay. So again, it looks good. Our asymptotes look good. Everything looks good. Now back on the assignment, you're just asked to move some points around here. It says use the green point to change the orientation of the transverse axis. Well, the green point is on the y-axis. The transverse axis is the y-axis, so I'm not going to move that green point. And the red key points to adjust the locations of the vertices. And now it says co-vertices. The co-vertice is not actually, the vertices, one of them is a 0, 4, right? That's actually a point on the hyperbola, and so is 0, negative 4, right? Those are actually points. This point they're having you move, they're calling it a co-vertex, but it's not actually on the hyperbola, right? It's just a guide. So remember I went up and down 4, that was the value of A, and then from the center I went right and left 6, that was the value of B, so I moved this to 6, 0. And this is the box that I drew by hand, and the asymptote should be going through the corner of these boxes. You got the vertices at 0, 4 and 0, negative 4. The branches opening up and down, right? The transverse axis is the y-axis. The conjugate axis is the x-axis. A lot of stuff, but this actually matches also the graph we had here. It should, right? The red graph we drew there. So finally, right, after you submit an answer, it'll tell you if you're right or wrong, and then give you some sort of answer explanation. Right? Please read through the answer explanations just to make sure you understand why something was right or wrong, and hopefully you can learn from your mistakes for the future. Now again, they're calling these things co-vertices. Please know that they are not actually solutions. Right? What they're calling the co-vertices here are not actually on the graph of the hyperbola. Right? They're not actually solutions of the equation. Right? And you can test it out by plugging in the x values and y values and seeing that they won't satisfy the equation. Right? All right, moving on. All right, so that was a long one, but the rest of them should be similar. I got a lot of that out of the way, so we could do very similar things for the rest of the assignment. So yeah, so here we're asked to identify the vertices, foci, and asymptotes of a hyperbola from some equation. And they're giving us equations that are already in standard form, it looks like. So that's very kind of them. Right. Okay. And here they're just asking for the asymptotes. So I'll write this equation, and we'll draw it out just like I did with the last example. Alright, so this equation we're given here is x squared divided by 9 minus y squared divided by 64 equals 1. So again, the center is at the origin. It's just x squared and just y squared, right? So the center at the origin, put a little dot there. Right? Again, that is not a solution, right? 0, 0 is not a solution. You'd have 0 minus 0 equals 1. It's just a guide. Now this is like that first case I went over a while back, earlier in the video, where you have the x squared term is the positive coefficient term, and the y squared term is the negative one. Right? In this case, the x-axis is the transverse axis. Right? The foci and the vertices will be on the x-axis, will be left and right of center. Alright, so the denominator here is 9 under the first term. That's going to be a squared. Right, a squared is always that denominator under the positive term. Right? It's not the bigger one like with an ellipse. And if a squared is 9, that means a is 3. And I'm going 3 units to the right of center to have a vertex, and then 3 units to the left of center to have a vertex. Right? So one of the vertices is at 3, 0, and the other vertex is at negative 3, 0. So plus or minus 3 comma 0. And again, you can check to see that these are actually solutions of the equation. Right? The vertices should actually be satisfying the equation. Plug in 3 for x, or negative 3 for x, and 0 for y, and you'll get 1 minus 0 equals 1, which is true. Right. Now for those asymptotes, we need the value of b as well. Right? So b squared is, the denominator under the negative term, under the y squared, that's 64. And if b squared is 64, then b must be 8. So from the center, I'm going to go up 8 units. And, I'm not going to put a point there. They have it in their graphs as a co-vertex, but that's not a solution. If x were 0 and y were 8, you'd have 0 minus 1 equals 1. That's not true. But it is going to help me form the graph, though, the asymptotes. So 8 units above the center, 8 units below the center, and then I'll form that little box, right, with a width of 6 and a height of 16 here. Right. All right, and through the corners of these boxes in the center should be the asymptotes. This is a bad hand drawing, I'm sorry. There's one asymptote, and then here's the other one. Again, through the center, through the corners of this box that you form. And then once you have the little box there and the asymptotes and the vertices, you should be able to make a very rough sketch by hand of the hyperbola. It's from the vertex. Just kind of follow along the box here for a little bit and start branching out, and then have it approach the asymptotes. Right, so again, that might be a crappy looking curve, but it's still going to be a curve. That all contains solutions to this equation, and same thing over here. Right, very similar looking. Okay, there it is. There's the graph of this hyperbola. Now the asymptotes, now that I have them drawn in, I can tell you what they are pretty easily. Well, they both have the origin as the y-intercept, so it's just going to be y equals mx, right, plus 0. And the slope of these lines is, for the one going up and to the right, the slope is rise 8, run 3, right? So 8 thirds. Y equals 8 thirds x. And, that's this line here, y equals 8 thirds x. And the other one just has the opposite slope. So y equals plus or minus 8 thirds x, y equals negative 8 thirds x. They have the asymptote should have opposite slopes. Okay, and then I know that that's all they wanted. Right, this is what I'm going to type in the assignment. But let me just to continue practicing. Find the foci. Right, so I need that value of c. Right, c squared is again a squared plus b squared for these hyperbolas. So that'd be 9 plus 64. So that's, c squared is 73. So c is the square root of 73. And again, the foci are on the transverse axis with the vertices. Now the square root of 73 is between 8 and 9 units. So 4, 5, 6, 7, 8, 9. Right? This is a horrible drawing, but there's the square root of 73 comma 0. That's one focus. And then negative 4, 5, 6, 7, 8, 9. Between negative 8 and negative 9 is the other one. There's a negative square root of 73 comma 0. Right, there's the other focus. Right? And if you were to take any point on the hyperbola, on this branch or on this branch, take the distance to each focus and subtract them, and take their absolute value if you did it the wrong way, the value will always be 6, or whatever 2 times a is, but I'm not going to draw that. And again, let's see how our thing looks compared to a better looking version. And back to Desmos here. I'll put in the equation we were given. X squared divided by 9 minus y squared divided by 64 equals 1. And yeah, there's those 2 branches, those 2 curves, one opening to the left and one opening to the right. You see 3, 0, vertex, negative 3, 0, also a vertex, so looks good. And then I'll put in the asymptotes, right, just to make sure that the curves are approaching the asymptotes that I said they would. So y equals 8/3 x, y equals negative 8/3 x. All right, and again, I'll make those the same color and dashed. Okay, and it looks pretty good. All right, and again, if you zoom out far enough, it should look like the curves, from the hyperbola almost become those lines, right? And it looks like that's happening here, right? If you zoom out far enough, it basically looks like those 2 lines, and that should be happening for any hyperbola, right? The graph will approach, the graph will get closer and closer to these 2 asymptotes running through the center. So great. Looks like what my hand drawing was is actually pretty good. But back here, right, all they want are the asymptotes, and they tell you how to put, they want you to use the plus or minus symbol here. So don't write 2 separate ones. Y equals, and then the plus or minus symbol is here in this little calculator on screen here, and 8/3 times x, right? Y equals 8/3 x, y equals negative 8/3 x. Those were the asymptotes. Wonderful. Again, please read through the answer explanations. Now, I know that you don't have to make a drawing to get these things. If you understand after a while what's happening with a hyperbola, you can pretty easily figure it out, what they want. All right. So here we're just same objective as the last equation. We're just given an equation here. This one has the y squared minus x squared, right? Like the very first example. And once again, I mean, I'll do a bunch of these until I get bored, and then I'll start just kind of speaking them out loud. But we have y squared divided by 16 minus x squared divided by 49 equals 1. Right, this is an equation of a hyperbola in standard form, right, but this time, like in the first example I did, y squared minus x squared. So the transverse axis is the y-axis, right? The vertices and the foci are going to be above and below the center. And the value of a squared, again, it's not the larger denominator, it's just the denominator under the positive term, is 16. So the value of a is 4, and I'm going above and below the center, right? So 4 units up for one of the vertices, 4 units down for the other vertex, right? So the vertices are at 0, 4, and 0, negative 4. Zero plus or minus 4. Right? All right, and then the other denominator, the one under the negative term, is b squared. It's 49, so b is 7. And I'm going right and left then, right? Right from the center, 7 units. And then left 7. Now again, I'm not putting points there because those aren't actually going to be solutions of the equation. Only the vertices are. But I will make that little guiding box, little dashed box here. And then through the center and the corners of these boxes go the asymptotes. So these asymptotes, I can tell you what they are right now. Right now, again, they both run through the origin, so the y-intercept is 0. It's just going to be y equals mx plus 0. When you put the equation down, y equals, this line has a slope of positive 4/7, and then the other line would have a slope of negative 4/7, right? So the asymptotes are y equals 4/7 x and negative 4/7 x. All right, but then and then again, once you have the vertices and the asymptotes in, you can draw a pretty rough sketch of the hyperbola, right? All the solutions of the equation should be like this, and approaching the asymptote as you go further out. So there's the two branches of the hyperbola. And then finally the foci, right? C squared equals a squared plus b squared. So 16 plus 49 is 65. Right. So C is the square root of 65. Square root of 65, which is a little bit above 8, right? So 5, 6, 7, 8. So a little bit above 8 units. There's the square root of 65. There's a focus. And negative 5, negative 6, negative 7, negative 8. A little bit below negative 8 would be negative square root of 65. There's another focus, right? So the foci would be at 0 and then comma plus or minus square root of 65. Right? And there's our graph. And again, you want to see how if this actually matches up. If everything looks good on the Desmos site, go ahead and do that. I'm not going to do it for every single one. All right, just for these first several. So the equation we're given, y squared divided by 16 minus x squared divided by 49 equals 1. And again, there's these curves opening up and opening down. There's 0, 4 vertex, 0, negative 4 vertex, like in my drawing. And then let me just make sure the asymptotes are correct. Y equals, one had positive 4/7 x. The other one was y equals, negative 4/7 x. And again, I'll make them the same color and dashed lines because they're not actually part of the hyperbola. And yeah, it looks pretty good to me. Looks like those two blue curves are approaching those green dotted asymptotes. And if you really want to be sure, just zoom further and further out and you'll see that the blue curves will basically start to look like those two green lines. The further you zoom out from center here, the closer those curves look to basically just being those straight lines. Right? They're not actually them. They're not actually touching them, but they get so close they look like they are. So yeah, it looks pretty good. Now they just wanted the vertices and the foci, so there. That was that first option, 0, 4, 0, negative 4, 0, square root of 65, 0, negative square root of 65. Which again, you could have done without drawing it, all that stuff. And eventually I'll get to the point in this assignment where I don't draw anything anymore. Alright, so back to graphing a hyperbola centered at the origin. And once again, we're given an equation here in standard form. And once again, I'll draw it by hand first. We'll look at the Desmos site, and then I'll come back to this. And I think that'll be the last one I do. And then I'll do a lot of other ones without drawing. So this equation, we have x squared divided by 36 minus just y squared. Now remember, if it's just y squared, that technically means it's y squared divided by 1. Now you can always put divided by 1, and it won't change the value of anything. Equals 1. All right, so again, the center's at the origin. Center's at the origin. The transverse axis will be the x-axis now, right? The lead term is x squared. It's x squared minus y squared. So a squared is 36, meaning that a is 6. So I'm going to the right 6 and left 6 for the vertices. All right, so the vertices are at 6, 0 and negative 6, 0. And then the b squared under the negative term here is 1. So b is 1. So I just go up 1, down 1. Again, I'm not putting points there because those won't actually be solutions. Those are just helpful as a guide. And I make that little rectangle. And then the asymptotes, right, go through the corners of this rectangle and through the center. So there's one asymptote. And here's, again, this is a crappy hand drawing, I apologize, but there's the asymptotes. And now that I have the vertices and the asymptotes, draw from the vertices here the curves, should be approaching these asymptotes as you move further away from the center. And these asymptotes, one of them would be y equals positive 1/6 times x, and the other one's y equals negative 1/6 times x. Right? Those are the asymptotes. And then the foci. Now this is all they wanted, right? But the foci, right? C squared is going to be a squared plus b squared, so 36 plus 1, which is 37. So c is the square root of 37, which is a little bit more than 6. So say the square root of 37 is here on the x-axis. There's a focus. I'll put f1 for focus 1. And a little bit less left of negative 6 would be negative square root of 37. There's the other focus. I'll call it f2. Alright. Again, let's just double check with Desmos. If our asymptotes are correct, this graph is correct. So putting in the equation they gave us, right, it was x squared divided by 36 minus y squared equals 1. See the curve opening left, curve opening right. The vertices are at 6, 0, negative 6, 0, so it looks pretty good. Now let me just make certain that my asymptotes are correct, right? That y equals 1/6 x and y equals, negative 1/6 x. Oops, x. Yeah. I'll make those the same color and dash them. Alright, and it looks pretty good, right? And again, if further you zoom out, it should look like the black curves touch, they don't actually touch the red dotted lines, but they look like they become them, right? So those are the correct asymptotes, right? And you could even zoom in and see that the black curve doesn't actually touch the red dotted line ever, but it gets as close to it as you want it to be. Great. So back in the assignment, remember the vertices were at 6, 0. Oh, and I want to change the orientation, right? Move the dot here so that the curves are opening left and right. Move the dot onto the x-axis, the transverse axis. And then again, they're calling them the co-vertices, but just, where the top of the box is, bottom of the box is 1 unit up, 1 unit down. A was 6, B was 1. And this should be good. This should be good. Great. All right. All right, so this time we're given some information and asked to write an equation. Write an equation. So write the standard form equation of the hyperbola that has these vertices and these foci. All right, so this one I'm not going to draw. Maybe I should draw a little, just so we can see where the transverse axis is, right? So they're telling us the vertices are at 0, 2, and 0, negative 2. Right, and the center is the origin, right? For all these problems in this assignment, the center is at the origin, and then 0, 2 is one of the vertices, and 0, negative 2 is the other vertex. So this tells me that the transverse axis is the y-axis, is vertical. And if that's the case, the equation is going to look like this. It's going to be y squared over a squared minus x squared over b squared equals 1, right? It's got to be the y squared minus x squared version if the vertices are above and below the center. All right, and they told us the foci are at 0 positive square root of 29 and 0 negative square root of 29, and that's between 5 and 6 units. So between 5 and 6 units, there's one focus, and then down here, -3, -4, -5, -6, there's another focus. All right, and we just don't know the asymptotes, so I'm not going to draw the hyperbola or anything yet. But we do know a couple things, right? All we need to do to finish this equation is find a and b. Right? You just need to find a and b. Now we know a. Remember, the distance from the center to a vertex was a. That's 2. So a equals 2, meaning that a squared, the denominator under the y squared there, is going to be 4. We also know c. Right? Remember, the distance from the center to a focus is c, and that's the square root of 29. Right? C equals the square root of 29, meaning that c squared is 29. But remember, c squared is a squared plus b squared. And we know that a squared equals 4. So we have 29 must be equal to 4 plus b squared. And then we can say, oh, b squared must be 25, and b must be 5, right? And so if I were to actually finish drawing this, I go right 5, right b, and then left 5. Right, I can form the box, form the little box and get the asymptotes in there. Right, the asymptotes running through the center and the corners of this box, and one of them is y equals 2/5 x. Right, the slope would be 2/5 rise over run, and the other one would be y equals -2/5 x. And then I could draw the rest of the hyperbola in something like this. But they're not asking us to do all that drawing, they just want the equation. And I know a squared is 4, b squared is 25. I pop those into the equation. We get y squared over 4 minus x squared over 25 equals 1. And this is what they want. Right? They want the equation of the hyperbola with those vertices and those foci. Right? Okay, and that's what I'll type in. Now, actually, I don't have to type anything. I just got to make sure I get the right one in the choices here, and that's this first one, y squared over 4 minus x squared over 25 equals 1. Excellent. All right. So another equation one, where this time, all right, I'll do one more of these where I draw it. The vertices are at 3, 0, and -3, 0, and the foci are at 3 square root of 5, 0, and negative square root of 3, -3 root 5, 0. All right. So again, a little drawing off to the side here. The vertices are at positive or -3, 0. So center's at the origin, right? So a vertex at 3, 0, a vertex at -3, 0, and that shows me that this time the transverse axis is horizontal, is the x-axis, right? And if the transverse axis is horizontal, then the equation's got to look like this. It's got to be that x squared minus y squared equation, not y squared minus x squared. X squared over a squared minus y squared over b squared equals 1. And I just need to find a squared and b squared now. They also gave us the foci, right, which are at plus or minus 3 root 5, 0. Now that's also square root of 45, right, because 3 is the square root of 9. So this is between 6 and 7 units. So between 6 and 7, there's one focus. And then between -6 and -7, there's another focus. And I just need to find, the asymptotes and be able to draw it. Right? Now we have A, right? A is 3, the distance from the center to a vertex. So that means A squared is 9. We also have C, right? C is the 3 root 5. Right? That's the distance from the center to a focus, 3 root 5. So that means C squared must be 45. And remember, C squared is A squared plus B squared. And I'm replacing A squared with 9. So 45 must be 9 plus B squared. And then just subtracting 9 from both sides, B squared is 36. And if B squared is 36, then B is 6. And I go up 6, down 6. Now I don't put any points there. Right? This is just helping me find the asymptotes. And then I can make the little rectangle here with the values of A and B, right? A is 3, B is 6, and I do this, and the asymptotes run through the corners and through the center. Now these asymptotes, this one has a slope of 6 over 3, but 6 over 3 is 2, so it's y equals 2x, and the other one would have y equals -2x as its equation. Those are the asymptotes, and I got the vertices and the asymptotes, and I can draw the curves approaching those asymptotes as I move further away from the center. And there you go, there's the graph, but they want the equation. Right. Now I have A squared is 9, B squared is 36. Just pop them in. So x squared over 9 minus y squared over 36 equals 1. There's the equation of the hyperbola that they were describing. And this one we're actually typing. Right, so x squared divided by 9 minus y squared divided by 36 equals 1. Wonderful. All right, now for most of the rest of the problems, I probably won't even draw anything out because I feel like I've done a couple in each objective now. Hopefully, and this video is already over an hour, so I'm hoping that you've seen enough to get a little handle on it. So yeah, here, didn't do each objective yet, but this one's just simply locate the vertices and the foci. And again, they've got these points here, but you see how they're in black, they're not in blue. So the co-vertices, they're not actually part of the hyperbola. So find the vertices and foci. Now, so here's a graph of some hyperbola. Right, the two blue. The hyperbola is just the two blue arches, right? The two blue branches. Identify the coordinates of the co-vertices. All right, so the co-vertices are on that conjugate axis. They're the ones that are not on the hyperbola. So 0, 8, and 0, -8 here. Right, the vertices would be 6, 0, and -6, 0, but the co-vertices, and then I would form that box in the asymptotes. The co-vertices are 8 units above and 8 units below. They're not actually solutions of the equation though, but 0, 8, and 0, -8 are the co-vertices. And I don't really like that they have those points there because again that probably is going to confuse some people, but those are not actually solutions of the equation. Yeah, so another pretty simple graph, right? Give the coordinates of the vertices. So again, this here's the center at the origin, 0, 2, and 0, -2, right? The two vertices of the hyperbola. Very simple, and we're asked to enter the ordered pairs separated by a comma. So 0, 2, comma, 0, -2. I'm pretty sure that's what they said. Yeah, give your answer as a list of ordered pairs. So there's a list of ordered pairs, 0, 2, and 0, -2 for the vertices. Great, yeah, this should be the easiest objective if they're giving you a graph and just asking you to identify certain points. So here's another one. what are the coordinates of the foci? Again, the foci are those points on the same line as the vertices. They're on the transverse axis and they're inside the curves. So that'd be 0, square root of 58, 0, negative square root of 58 here for the foci. 0, comma, and square root of 58, comma, and then another one, 0, comma, negative square root of 58. Close the parentheses, and that's a list of ordered pairs that they want. Great. Alright, one more of these. Again, probably because they're so quick, they're just bunching them all together. What are the co-vertices again? So that's these points here on the conjugate axis that are not actually part of the hyperbola. 0, 7, and 0, negative 7. For the co-vertices, right? 0, 7, comma, and then 0, negative 7. Alright, that should be it for that objective. Pretty easy one in my opinion, that objective where they're giving you a graph. Alright, so this one, see how it's y squared minus x squared. So the vertices will be on the y-axis, and the vertices will actually be at 0, 7, and 0, negative 7, and they ask you to enter it with the plus or minus symbol. So 0, and then plus or minus should be in the little boxes here. 7. And then the foci are going to also have an x-coordinate of 0, right? They're also going to be on the y-axis. The foci should be on the same line as the vertices. We just need that c. Remember, c squared is a squared plus b squared for a hyperbola. 49 plus 36 is 85. Alright, so square root of 85 and negative square root, 0 square root of 85 and 0 negative square root of 85 will be the foci. So 0, comma, plus or minus the square root of 85, which doesn't simplify any further. Right, that's good. Wonderful. Alright, and again, read through the answer explanations if you need to. Here, what are the asymptotes? So again, we're asked to write y equals mx, y equals slope times x, and then the y-intercept is going to be the origin, right? Both these asymptotes run through the center, which is 0, 0, so their y-intercept is 0. Now again, a squared is 4, so a is 2. I'd go up or down 2 for the vertices, so the rise is 2 or negative 2 for the slopes of these lines. And then b squared is 25, so b is 5. I'd go right or left 5 to get to those co-vertices, right, to form the box. So up 2, right 5, down 2, right 5. The slopes of the asymptotes will be positive or negative 2/5. So the lines that'll be the asymptotes are y equals positive or negative 2/5 times x. Right? Alright, then write the equation here again. We know that this is right. These vertices are to the right and left of the center, so the transverse axis is horizontal, right? So it's going to be x squared minus y squared, x squared over something, right? Over a squared, and a is 2, right? From the center to 2, 0, or negative 2, 0 would be 2, so a squared is 4. So x squared over 4 minus y squared over, and then I need to find b squared. Well, c would be the square root of 53, right? So c squared would be 53, and that would be a squared plus b squared, but we know a squared is 4. So subtract 4 from 53, that's 49. 49 is your b squared. So y squared over 49, and then equals 1. So x squared over 4 minus y squared over 49 equals 1 would be the equation of the hyperbola described up here. Again, like I said earlier, I draw a bunch of these. You don't have to draw them, as you've noticed me just speaking out loud what I'm doing here. All right, so another write an equation one. Again, we're given the vertices and foci, but this time it'll be a y squared minus an x squared. because the vertices and foci are above and below the center of 0, 0. So y squared over a squared, and a would be 3, so a squared would be 9. Y squared over 9 minus, and then x squared over b squared, which I need to find. Now a squared is 9. C squared would be 25, right? Because C is 5. The foci are 5 units away from the center. So 25 equals a squared plus b squared. 25 equals 9 plus b squared. Subtract 9 from 25, that's 16. So b squared is 16. You'd have x squared over 16. Y squared over 9 minus x squared over 16 equals 1. There you go. So yeah, with enough practice, hopefully you can get this quick. And then the graphing. So here's an equation that is not in standard form. So this one I'll actually write out. We got to put this in standard form, and then we can do the graphing and stuff like usual. Right? So the equation we're given here, we have x squared minus 4y squared minus 4 equals 0. And I'm going to put this in standard form by, the standard form, I want x squared over a squared, because I notice it's a positive x squared, negative y squared. So it's going to be one of these, x squared minus y squared over b squared equals 1. We want this. So the variable terms on one side and constants on the other. So I'm going to add 4, make sure the variable terms are on their own side. And then, it needs to be equal to 1, not 4. So I divide by 4. Let's say divided by 4 on both sides. So we have x squared over 4 minus, and then just y squared, right, because the 4's cancel if I divide that second term by 4, equals 1. Here's the equation in standard form, which I'm going to do this very quickly. I'm not going to change colors or anything. The vertices would be at 2, 0 and negative 2, 0. I'd go up 1 and down 1 for those co-vertices, 0, 1, 0, negative 1, but that would form this little box here. Got the asymptotes going through the corners of the box. And then the hyperbola looks like this. All right. So yeah, 2, 0, negative 2, 0 for the vertices, and then again those co-vertices would be at 0, 1, and 0, negative 1. The asymptotes would be y equals 1 half x and y equals negative 1 half x. But they're not asking for that, right? They just want the graph. So need to change the orientation, make sure the branches are opening left and right. The transverse axis is the x-axis. Vertices at 2, 0, negative 2, 0, great. The co-vertices at 0, 1, and 0, negative 1. So there's your graph. Wonderful. But yeah, you got to get that one into standard form first. Alright, this should be the last one based on my progress. And it's another one where it's not in standard form, but I'm just going to talk this one out. We'd end up with x squared minus y squared over 4 equals 1. So, x squared is the positive term, so it's an x squared minus a y squared, so it's going to be left and right branches like this. And then it's x squared over 1, so 1, 0, and negative 1, 0 are the vertices, and then minus y squared over 4, so 0, 2, and 0, negative 2 will be the co-vertices, and this is your graph. Right? I'm going to leave the whole putting it in the standard form to you. Wonderful. All right. And again, with enough practice, I'm hoping you can get that quick. And that should be it for this preview version of this assignment. Now, like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. And thank you very much for watching.